Scratch-built remote control plane. Will it fly? For a long time now, I've wanted to build a remote control plane of my own design completely from scratch. Starting a couple years ago, I built my first partially successful prototype as a collaboration project. Since then, it's been an incredibly difficult task to build a plane that doesn't end up smashed to bits after each flight. Building model after model and crashing most of them within the first couple of seconds was understandably frustrating, because every bad crash would mean weeks of rebuilding. Repeatedly crashing my unproven model planes did not seem like the best way to learn flying skills, so I got a trainer plane to practice with. It was equipped with a number of adjustable features, had varying degrees of gyro stabilization, and was most importantly extremely easy to fly. I could also learn a lot from its construction and maybe, just maybe, have a stable and controllable design of my own. After several weeks of much needed practice, I was now able to land smoothly and consistently bring the plane back with no damage. I started building a larger version of the trainer plane with readily available materials such as poster board and fiberglass tent tubes. I used a rear propeller and a 3-segment wing with a slight dihedral at the tips for added stability. It is now time to see if this was airworthy. Okay, it got up, but it didn't turn. Unfortunately, this plane had some issues with roll control, with its right wing dropping irrecoverably as it began to turn. This crash was bad enough to break most parts of the plane, so it needed to be completely rebuilt. It also appeared that the wing may have stalled from too much aileron input, so I changed the method of roll control to a split elevator instead. I tried using a 3D printed ducted fan to power the next plane as it wouldn't induce any unwanted torque. It produced about 22 newtons of thrust, which was more than adequate for my small model, and it didn't even draw that much current. Surprisingly, while doing a routine thrust test, my motor stopped abruptly and the speed controller started spewing flames. Thankfully, the plane didn't get burned too badly or catch fire, but my motor and speed controller were both thoroughly destroyed. This meant I had to resort to a less powerful commercial version and hope it would provide enough thrust. Oh no. Okay. Oh no. Obviously, the replacement thruster was nowhere near powerful enough to prevent the plane from stalling and losing control as soon as I attempted to pitch up. From about a dozen failed launches, the airframe was also badly damaged, meaning I had to scrap the design and find a more powerful propulsion system. After even more practice with the trainer, I rebuilt the plane using only the wings from the last version. I used twin wing-mounted propellers, which gave the plane a thrust to weight of 0.7 at full power. This should be sufficient for a field takeoff and a reasonable climb angle. I also reduced the weight so that it would have a lower takeoff speed. Now it's time for the first flight.
Alright. Alright. Yeah, look at that. It's about 30 feet up. Not in the trees. Yeah, let's control it away from the trees.
Dang it. Ah, tree. Although it ended up in a tree, this is a very promising result, so I recovered and tried again.
So it's up about 40 feet now. Yeah. Nice landing.
This time it flew amazingly well, showing full controllability in all rotational axes. It was capable of maintaining a moderate climb rate, and once the trim was dialed in, it would still fly level when I let off the control sticks. I even tried to fly it with FPV goggles, although the video feed had some bad interference at full power. It was almost as maneuverable as the trainer plane, but had no panic button or gyros to avoid crashing, so I didn't push my luck with any crazy maneuvers. I flew the plane until the battery ran out, which totaled in at about 7 minutes of flight time. This design could definitely be optimized for better efficiency because the trainer plane can fly for over 30 minutes on the same size of battery. The biggest reason for this inefficiency was because the propellers were slightly oversized for the motors. This gave a higher takeoff thrust, but at the cost of efficiency. The higher load on the motors led to things getting hot and the 3D printed mounts warping from prolonged use. Using a smaller propeller with a lower pitch would likely help somewhat with this problem, as well as making the motor mounts out of a non-meltable material. Overall, this project has surpassed the goal of stable flight with my own plane design flying almost as well as the trainer. This has been a very difficult thing to achieve, but with enough research, testing, and iteration, this project finally got off the ground.
Not in the trees. Yeah, let's control it away from the trees.
Dang it. Tree!
Yeah, the tree ate it. And there he goes. Yeah. Jump. Well, that's fun. A boy and his tree. Ninja-like reflexes you got there.
Oh no! We actually fought. And mine's fine. And mine's completely fine.